Hi. Um, so to explain why I chose Rookie of the Year is because given the limited time, we really wanted the data that would be the simplest to extract, but also be the most indicative of the actual Rookie of the Year or whatever award we're predicting. Rookie of the Year specifically does not have as much historic context, and although in my modeling I would have liked to include past playing leagues, such as Luka Doncic playing in a professional league versus college versus neither, we just didn't have enough time to do this. And in addition to that, another time-saving method that I used was instead of creating the API myself, since we're not extracting new novel data, everything's numeric, string or like a binary. I decided to just pull it directly from a Kaggle data source that had everything I needed. This specific source pulled from Basketball Reference, and instead of investing time into the API, what I instead did is I set up a quick Snowflake database through mass CSV imports and decided to toy around with the data myself. With that being said, it was, in my opinion, much easier to document all of the assumptions we made, data casting, such as only extracting 2000s. This was just for like convenience and importance. I documented all of our assumptions, all of our join methodologies. The forecasting was easier, and you will have access to this. I'll send you all of the login info in the original email. One other thing is that it made the exploration much easier. It makes it much more indicative or intuitive to see what players are missing from the data set, if it's acceptable or not, things like this. But after extracting the data set from Snowflake, we imported it through CSVs into Python, which is where all of the modeling took place. So we use the standard data science models, sklearn, matplotlib, et cetera, et cetera. We had around 1,500 data points for rookies since 2000, which makes sense. And we also only use a random forest classifier. Good machine learning practice is to explore different models to use, see what the performance is, overtuned, undertuned. But for the sake of efficiency, I chose random forest because of this function right here, feature importances, which tells us essentially if we format our data correctly, what are the most important features, being points total, field goals attempted, and minutes played, which does make sense to me. And if we just quickly scroll down here, we can see that the Rookie of the Year candidates from previous seasons all score in the top percentiles, meaning that our model understands this and should be predicting based on this. One other thing to mention is that because of the uneven distribution of the data set, it was really important to see if we should introduce any cutoff to maybe instead of having one rookie of the year for every 60 non-rookie of the years, make it a little bit more fair. And so we explored different point cutoffs from 2 to 1,000, and we did see an increased trend at the cost of course, data set size. One other important thing to note here is that normal classification scores obviously don't mean anything, since if you just guess not rookie of the year 99% of the time, you would be accurate. And so my scoring methodology for this was the accuracy on positive classes, meaning how many rookie of the years won rookie of the year versus what we scored as rookie of the year. Um, but with that being said, after evaluating the score, saving the model that had the best performance, giving this positive label attribution, we decided to move on to our predictions for the current year. One key assumption I had to make here is that we had to forecast the data to 82 games, and without considering the games skipped, we saw a couple of abnormalities I'll get into in a second. Um, but skipping ahead, you can see that our top three performers is VJ, Dylan Harper, Cooper Flag, makes sense, but also Ryan Kalkbrenner, which perfectly explains some of the pitfalls of this model, all of which I've explained here. But with Ryan specifically, the reason he performed so well is because he only played a couple of games, and we still extrapolated that to 82 games without considering the fact that he was benched half the games. He was elite in some of these stats like blocks, really good in scoring, field goal percentage, the things that influence the model. Thank you.